Okay, so how do we capture sound waves and turn them into electrical current, which we can then use to record? Well, there are several different ways of capturing sound, but we'll cover the most common ways of recording. The simplest is the dynamic microphone. In a dynamic microphone, a thin diaphragm is connected to a coil of wire called a voice coil, which is precisely suspended over a powerful magnet. As the sound waves strike the diaphragm, it causes it to vibrate, moving the voice coil through the magnetic field generated by the magnet, and it generates a small bit of electricity which is sent down the output leads. This is our audio signal, an electrical representation of actual sound waves. Now, the advantages to the simple and robust design of the dynamic microphone is that it can handle loud sources without much distortion. Now, unfortunately, this makes them weak when trying to capture soft, distant sources because the diaphragm needs a lot of sound energy in order to move. A variation on the dynamic microphone is the ribbon microphone. Instead of using a coil, ribbon microphones use a small strand of very thin 2-micron thick aluminum ribbon. This ribbon is much more responsive to the high frequencies, with the drawback that the ribbon is fragile and prone to tearing. Now, ribbon microphones are almost exclusively used in the studio and not for location audio because of their fragility. The final type of microphone commonly used in film is the condenser microphone. Now, condensers use two electrically charged plates, one fixed and one which can move, acting like a diaphragm. Unlike dynamic mics, there is no coil. Instead of using electromagnetic principle, condenser microphones use the electrostatic principle. The two charged electric plates creates what's called a capacitor. As sound waves strike the electrically charged diaphragm, it moves in relation to the fixed plate, changing the capacitance and generating a very small electrical charge, which is then amplified inside the microphone and sent off to be recorded. Now, the advantage of condenser microphones is their response. Because you're not moving a coil, condensers can be more responsive in the high frequencies. And because we don't have any magnets, condenser microphones can be made very, very small. Because condensers work with electrically charged plates, that means they require some sort of outside electrical power. Now, some microphones have the option of an onboard battery, while all condenser microphones can utilize something called phantom power, which is a plus 48 volts from a audio recording machine or a mixing board. There's not one microphone that is perfectly suited for all applications. We've already covered 3 kinds of sound conversion technologies. Let's take a brief overview of the kinds of microphones that are used in film and video production. Of course, we're only going to scratch the surface of what's available. When choosing a microphone, we have to consider the directional response, which oftentimes is represented by something called a polar pattern. Now, there are a few common types of polar patterns. The omnidirectional pattern means the mic is responsive to sound from all directions. You don't have to be on axis in order to be picked up. These mics are useful for picking up sound in a general area, but the drawback is they will pick up all the unwanted sounds in a general area. An example of an omnidirectional mic is this Rode Reporter mic, which is designed for news interview applications. You don't have to point it directly at the source, you just have to get it close to the speaker. Now, directional mics are a bit more picky about what they can hear. The most basic is the cardioid pattern. Now, notice how it picks up what's in front of the microphone on axis and not what's behind it. An example is the Rode M1 mic, a dynamic microphone that is suited for live performance as it picks up sound on axis but won't pick up what's behind it, like crowd noise or feedback from a loudspeaker. The Rode NT55 is an example of a cardioid condenser microphone, which has the option of switching between cardioid and omnidirectional. The NT55 and other large diaphragm condenser mics like this beautiful sounding Rode NT1 are well suited for voiceover and other studio recording applications. Now, more directional are the hypercardioid and supercardioid polar pickup patterns. The Rode NTG2 shotgun microphone is an example of a supercardioid mic which picks up the front and the sides and rejects 150 degrees to the rear. Now, this condenser microphone used in conjunction with a boom pole is a great solution for recording location audio and trying to filter out some of that unwanted ambient sound. Now, for working with even noisier situations, you may look into something like the super long Rode NTG8 microphone, which is great for noisy outdoor use. Now, some condensers and ribbon microphones will feature a figure 8 pickup pattern or a bi-directional pickup pattern. Mics like the Rode NT2000 can be switched into bi-directional pattern, which is useful for certain musical applications. Now, there are two other kinds of microphones that will have a place in film and video production that we haven't talked about. The most common is the lavalier or lapel mic. Mics like the Rode lavalier and the really awesome sounding pin mic are small condenser microphones with an omnidirectional pickup pattern that are designed to be placed on the talent in order to capture sound. They work on proximity, and when combined with a wireless transmitter and a receiver can offer the most freedom and flexibility when recording audio. But because of their small size and the placement on the body of the talent, lavalier microphones just won't have that same richness of sound as a shotgun or a studio condenser mic. Now, another useful type of mic is called the boundary mic. Now, boundary mics are omnidirectional condenser mics that are positioned flush with a surface and capture sound as it rolls off that flat surface. Boundary mics are very useful when recording stage productions. So between handheld mics, shotgun mics, studio condensers, lavaliers, and boundary mics, these will be the microphones you will need for the vast majority of the situations you will encounter when making films and video. Now remember, sound is a crucial part of the filmmaking process. In some cases, getting good, clean sound is actually more important than getting a decent picture. Now, we've just scratched the surface of the science of sound and microphone technology, but now it's up to you to research and experiment with recording sound. Go out there, make something great. I'm John Hess, and I'll see you at filmmakeriq.com.